All right, in this problem, we're going to solve an equation, x plus 3 to the 1/2 power minus 4 times x plus 3 to the 1/4 power equals -4. Now, if we just had x plus 3 to the 1/2 power and no other variable raised to a different power, like if this was a 1/2 power, or maybe this whole variable wasn't here, then you could isolate this and square both sides, all right? And you could sort of use a strategy like that here, but the degree, you would have to raise both sides to the 4th power to get rid of this. And it does get really complicated. So raising the degree on both sides of an equation is a strategy you don't want to use right away. It's more of like a last resort. And you're only really going to do that when the index is the same for all the variables, right? If this was a radical, it would be a square root. If this was a radical, it would be a 4th root. Those are different indexes. So that means you kind of want to try to avoid raising both sides to a power. What we do have is an unknown quantity and then the same unknown quantity raised to two different exponents, but those exponents have a ratio of 2 to 1, right? 1/2 is double 1/4, 1/4 is half of 1/2. When that happens, you could treat it like a quadratic. You can let A equal the unknown quantity to the lower power, all right? And then if you square both sides, because 1/4 is half of 1/2, when you square both sides, 1/4 times 2 is 1/2. You get a squared is equal to x plus 3 to the 1/2 power. Now, if we substitute, we get a much simpler equation. Okay, so by substituting, and again, you're going to do that when you notice that your unknown quantity is raised to a certain power, and then the same unknown quantity is raised to a power either half or double that. That means you could treat it like a quadratic and do substitution. And you really break this complicated equation up into two simpler equations. All right, this one right here, which we could solve, and this one right here. So you're really setting up a system of equations. You're taking a complicated thing and breaking it into two simpler things. So now we got to solve this. So we get a squared minus 4a plus 4 is equal to 0. Factor, you get a minus 2 squared. Sorry, I got to let someone in the Zoom. All right, we get a minus 2 squared is equal to 0, which means you take the square root of both sides, and you get a minus 2 equals 0, a is equal to 2, okay? Now that we know a is equal to 2, we can take a and replace it with x plus 3 to the 1/4 power. And then solve that equation by, now we'll raise both sides to the 1/4 power, because again, we only have one index in this equation. It's a 4th root. So when we raise both sides to the 4th power, it's a lot simpler. And we get x plus 3 is equal to 16, subtract 3, and you get x is equal to 13. All right? And if you plug it back in, it might work or it might not work. You could have an extraneous solution. So let's check it out. All right, if we plug that in there, we get 13 plus 3 to the 1/2 power minus 4 times 13 plus 3 to the 1/4 power equals -4. So this is the square root of 16, which is 4, minus 4 times the 4th root of 16, which is 8. 4 minus 8 is -4, so it checks out, all right? Always check your solution and be mindful that in rational equations and in equations that have radicals or rational exponents, because of domain restrictions and raising the degree of both sides, you could get extraneous solutions, but that's not the case here. So our answer is x is equal to 13. Oops, where'd it go?